All right, Math 9, here we go again. We're continuing on our exponent journey. So we're looking at power to a power and zero power. So what does that even mean? Well, we've seen multiplication of a common base, where we had two exponential terms and we multiplied them together. So that was what that looked like. And then we had division of a common base, where we subtracted our exponents. So power to a power is when you have a statement that looks like this. You have a power to a power. Math people are not very creative. This is literally what we just call it exactly what it is. So what does it mean when you have a power to a power? Well, it means you have all of this to this power. So if you think repeated multiplication, it means we have this times itself, which then in turn means we have all of this. So if you think about what's going on here, look, we end up with 6, right? What is 6? Well, this is addition because we're multiplying. And what's repeated addition? Talked about at the beginning of the very first exponents video, multiplication. So in this case, what we do is we multiply our exponents together. We get 2 to the power 6. So that's what power to a power looks like. So what do we do here? Well, it's 2 to the power of 4 times 2, so 2 to the power of 8. We multiply the exponents, 3 to the 2 times 5, 3 to the 10. So that seems really easy, and it is kind of easy, but obviously it's going to get a little bit more complicated because in this case, forever positive and forever negative is really confusing because you can't just say, oh, well, that's going to be negative 2 to the 8 because maybe it's going to be negative 2 to the 8, and those are very different things, so how can you tell? What it comes down to is asking, is the inside positive or negative, but then also looking at, is the outer exponent even or odd, because this exponent here is even, which means it doesn't matter what's on the inside. Anything to an even exponent is going to end up positive. So this would be forever positive because it's an even exponent. So this would give us 2 to the power of 8. Whereas in this case, we have an odd exponent in the end. And on the inside, it's forever negative. So it means we're going to have a negative number to an odd exponent, which means we're going to have a forever negative. So this would be a negative 3 to the 10. You're not going to see this a lot, but it's important to be able to determine the difference between the two. It comes down to the exterior exponent only. Is it even? Then it's positive. If it's odd, then it's most likely going to be negative. So what about a fraction as a base? Well, in this case, you got to consider the fact that you have 2 over 3 times 2 over 3, which means you would have 2 to the 2 over 3 to the 2. So what that means is this exponent has to multiply into that exponent and into that exponent. So you can see that in play here. This needs to multiply into here and into there. So you'll get 3 to the 2 times 5 over 4 to the 3 times 5, which gives us 3 to the 10 over 4 to the 15. And we cannot do anything more here because we do not have a common base. Now, when you have powers on the outside, what a lot of people do here is now they'll start saying, oh, well, he just said multiply the power in. But you can only do that when you are multiplying. And here we are adding and subtracting. So in this case, we cannot do that. All we can do in this case is our good friend BEDMAS, section 1.5. We have to simplify the inside first. So this means it's 5 squared, which is 25. This is 4 cubed, so 4 times 4 times 4, 64. And this is 3 squared, which is 9. If you were to multiply that exponent in, you get something completely different, right? Here we're going to get 4 plus 9, which is only 13. So very different. So we cannot just multiply the exponent in when we have addition or subtraction on the inside of our brackets. We have to do that operation first, BEDMAS. If you have multiplication on the inside, then you can do either one. So let's see, if we were to multiply those together first, we're going to have 6 to the power of 2, which means we're going to have 36. But otherwise, we're going to have 2 to the power of 2 times 3 to the power of 2, which means 4 times 9, which is 36. So when you have multiplication on the inside, you can do either one you want. I mean, it's still always nice to multiply them together because it just makes life easy. That's negative 12 squared. We don't have to worry about our forever positive, forever negative because it's even exponent. The answer is positive. 12 times 12, 144. Here it would be 10 squared, which is 100. But that's the same as saying, okay, well, 5 squared times 2 squared, 25 times 4, 100. So when it's multiplication on the inside, you can do either option. But if it's addition or subtraction on the inside, it has to be inside first, all of that to the exponent. That is a very common error, so let's tighten that up here. Okay, so now what about zero power? So let's look at this in two ways. First way we're going to look at it is this, constant division. So if I have 3 to the power of 5, what does that mean? That means 3 times 3 times 3 times 3 times 3. And then 3 to the 4, well, 3 times 3 times 3 times 3. 3 to the 3, well, that's 3 times 3 times 3. 3 to the 2 is 3 times 3. 3 to the 1 is 3. So 3 to the 0 is what? Well, to get from here to here, I divided by 3. Here to here, I divided by 3. I divided by 3. I divided by 3. So what's 3 divided by 3? It's 1. That's right. 3 to the power of 0 is 1. It's not 0. It's never 0. 3 to the power of 0 is 1. There's a connection we can make there to get into negative exponents, but we'll save that for a bonus video. Now, what about proving that using common base? So I just told you that 3 to the power of 0 is equal to 1. Well, let's look at this through a series of equal statements. Because if one statement is equal to the next, they're all equal to each other. This is something that we often abuse because we put it in an inappropriate scenario, but this will work. Think about our division law. When we divide a common base, we subtract exponents, right? So that means if we had 3 to the 3 over 3 to the 3, what would we do? We would subtract. So we would have 3 to the 3 minus 3. Now, is it true that this is equal to this? Yes, it sure is. Is it true that this, anything divided by itself, is equal to 1? Well, it sure is. And it's true that these are equal to each other because that's my division law. So through that, it's proved that that is equal to that. So anything to the power of 0 is equal to 1. So here we go. 3 to the power of 0, what is it? It's 1. 2 to the power of 0, what is it? It's 1. This lovely statement where we got to do some bed math, do we? No, we don't. It's all to the power of 0. So no matter what's in there, it's going to be 1. So whenever you have 0 as the most outside exponent, your answer is 1. So you're thinking to yourself, is there a catch? What's going on? This is too easy. It is pretty easy. But we just got to worry about the negatives. Because remember, here, no brackets. This is a forever negative statement. This means negative 1 times 3 to the 0, which means negative 1 times 1. So in this case, my answer is negative 1. Where in this case, all of my stuff is to the power of 0. Doesn't matter, it's a negative in there. Everything in there is to the power of 0, so this is positive 1. So the gist is no brackets, negative 1, brackets, positive 1. So that's it for power to power and 0 power. Keep watching, keep learning, keep going. You're doing great.